wanna go home. I wanna go home.
우리가 만나 그거면 됐다 널 사랑했다.
Welcome to a video that I put all my blood, sweat, and tears in. Originally, I was going to make a PowerPoint for my microbiology class to teach them about Helminths. Then I realized that this wasn't going to be enough for a full lesson, so I decided to teach them the entirety of Unit 5, Eukaryotes of Microbiology. Bad idea. This was a lot. Like, a lot. And very hard too. I took approximately about 15 plus pages of notes, only to reread my notes, realized that I had no idea what I was doing, and then had to take a whole new set of notes again. And that's when I realized that a PowerPoint just wasn't going to cut it. You see, microbiology is not like history where you can read a textbook, and it's not like chemistry or physics where you have to apply the math skills. It's a lot more diagramming, a lot more memorizing, and a lot of connection to different groups here and there. So that's why I made this video. Hopefully the visuals paired with the explanation will help you guys learn quicker and easier, and you won't have to sit and cry behind a desk reading a bunch of fluff like I did. Now, let's get on with it. Quick disclaimer, all information can be found on openstax.org. None of the information or the photos belong to me. I'm just summarizing it for educational purposes. Let's start off with the hardest one, unicellular eukaryotic parasites. These cover a huge range of different organisms. Despite the unfamiliar name, you have definitely heard of some of these before. For example, malaria. That's right, friends. Malaria is not a virus. For all my life, I could have sworn that malaria was a virus, but it isn't. It is a protist, or a group of microscopic eukaryotic organisms. Pretty vague, right? Well, protists don't really have a shared evolutionary origin. It's just everything that isn't a plant, animal, or fungi. There are three main types of protists, which are animal-like protists, plant-like protists, and fungi-like protists. But for 5.1, we're going to focus on animal-like protists, also known as protozoa, non-photosynthetic, motile unicellular organisms. Remember, children, protozoa are not interchangeable with protists. Protozoa are protists, but not all protists are protozoa. Maybe this is common knowledge and I'm just an idiot, but I always thought these two are the same thing. But anyways, let's dive a little deeper into protozoa. Protozoa can be found almost anywhere, whether it's on land or in water, and they can be parasitic, live freely, or can be both beneficial and harmful to humans. And protozoa are usually trophozoites, which is the feeding and growing stage of their cycle. They can also turn into a cyst if their external environment isn't suitable enough through encystment. Now, there are a couple ways how protozoa can reproduce. Asexual-wise, they can go through binary fission, budding, and schizogony. Sexual-wise, they can go through synogamy or conjugation. There are also a couple special features of protozoa. First, there's the plasmalemma, or the plasma membrane. If there are special bands of protein in the plasmalemma, the membrane becomes thicker and is called the pellicle. The cytoplasm, unlike animal or plant cells, are divided into two parts, the ectoplasm and the endoplasm. Some have a cytostome for phagocytosis, where the food can travel to the vacuoles, and a cytoproc to get rid of waste. And of course, there are different ways protozoa can quote-unquote eat. Holozoic protozoa ingest whole food particles, while saprozoic ones eat smaller food particles. Flagella, cilia, and pseudopodia all help the cell move. Contractile vacuoles, mitochondria, and kinoplastids are all possible organelles of protozoa, but since protozoa are such a broad group of organisms, there is a lot of variety. So, how can we classify protists and protozoa if they are so broad? Well, every single protist can fall under one of the 6 eukaryotic supergroups: Excavata, Chromoviolata, Amoebozoa, Rosaria, Archaeplacida, and Opisthocanta. We're just going to focus on the first 3. And to help you guys memorize this, because it's going to be a lot, I'm going to compare it to a restaurant food item and its toppings. You'll see what I mean. I'm sure it's going to help. Excavata, which will be our burgers, include primitive eukaryotes and some parasites, which can be further divided into 3 subgroups: Fortnicata, Parabasalia, and Eugenozoa. Fortnicata, our hamburger, have no mitochondria but have a flagellum. Parabasalia, our turkey burger, are animal and symbionts, have basal bodies, gynoplastids, and many flagella. Lastly, Eugenozoa, our vegan burger, have 2 flagella, a pellicle, a stigma, and chloroplasts. In the description box below, I've linked a document where you can look at a bunch of examples of each of these many classifications, as well as a list of important definitions for all of Unit 5. Because if I were going to go through every single one of these, this video would be about 3 hours long. I will also link an interactive quote-unquote restaurant menu for 5.1 as a reference sheet. You're welcome. Now, are we ready to move on to the next supergroup? Absolutely. Our next item on the menu is Chroma violata, or our pizza. All organisms here have similar origins of plastids and include the acomplexians, ciliates, diatoms, and dinoflagellates. And of course, we're only going to be covering the first 2 in 5.1 because diatoms and dinoflagellates are further discussed in 5.4. Acomplexians are our traditional Italian pizza in this example. These are parasitical cells with an apical complex at the end and a sporozoite that reproduces through schizogony. This could infect humans, not the Italian pizza you want to eat. Moving on, ciliates all have cilia on their cell surface. Surprise, surprise! Who would have guessed? This is our New York style pizza. The cilia can be used for movement or for feeding, as some ciliates are non-motile. They also have 2 types of nucleuses, a micronucleus and a macronucleus. Cilia also have a pretty complicated reproducing process, which I refuse to explain because in all honesty, I have no idea what is happening here either. But hey, this is high school microbiology, so it shouldn't be too big of a deal. And if you're a college student watching this, wrong video, buddy. Wrong video. Last but not least is amoebozoa. It's our hot dog, because it's simple. And boring. Amoebozoa all use amoeboid movement, which is movement with the pseudopodia. Some of them are parasitic, and some of them make slime molds, which I don't find very important, so I'm skipping that part too. And that's pretty much it. That's all there is to 5.1. I want you to give yourself a pat on the back because that was a lot. But don't worry, 5.1 is the hardest section in Chapter 5 because there's just so much to memorize. It will get easier from here. Got your drink of water and your meal all finished? Good. We're gonna get out of the restaurant and move on to Helminths, my personal favorite. Alright, Helminths. This should be a fairly short and easy section to cover, unlike the first one we just did. Helminths are a parasitic worm, and they are usually multicellular and have organ systems, although they are limited compared to other animals. They also have reproductive cycles and can live in multiple types of hosts. There are 2 reproductive groups for Helminths. They can be either monoecious or dioecious. But the main categories we put Helminths in are their shape. They can either be a flatworm or a roundworm. Roundworm, or nematoda, are unsegmented worms with a full digestive system, and their eggs can be found in feces or one's anus. These are nasty stuff. This whole section is nasty. You've heard of a few of them, including pinworm and hookworm. If you click on the document in the description box, you will also find a bunch of examples of both roundworms and flatworms. One of my favorites is the Ascaris lumbricoides. Ingested through contaminated food, these things can burrow into your intestine, stunt growth, and cause pain. But the best part is that these are huge. Some females can reach up to 1 meter. 1 whole meter. Jesus Christ, just the thought of 1 meter worm crawling in my body really sends shivers down my spine. On the other hand, flatworms, or platyhelminths, can be divided into flukes and tapeworms. Flukes are non-segmented and have an oral sucker that can attach to many different organs in one's body. They have complex life cycles and can infect multiple hosts. Tapeworms are segmented with a hook or sucker at its scolex, which mainly attaches to the small intestine. Proglottis, which are the segmented parts of a tapeworm, contain reproductive structures that detach when gametes are fertilized, which then hatches into an oncosphere. The oncosphere moves to a certain organ where it settles and turns into cystery, and then grows into adult tapeworms. The thing about tapeworms is that their oncospheres can travel out of the organ it primarily settles in and relocate somewhere else, spreading everywhere. You ever wonder why people always make such a big deal of eating uncooked pork? Well, uncooked pork can contain T. solium, a tapeworm that can travel and colonize other parts of your body, if unlucky, including, drumroll please, the central nervous system. Yeah, I don't think we want worms in our brain hatching and crawling and... No, absolutely not. Now, before we lose the lunch that we had earlier, we're going to transition out of helminths. No more worms. But actually, before we do, one important thing to note. A ringworm is not a worm. It is not a helminth. What do you guys think it is? Yeah, it's a fungi, which is what we're going to cover next. Fungi. Fungi! We are 3/5 of the way there, people. Well, technically a little bit more than that, since the last 2 sections should be fairly quick. You've seen fungi before. You know what fungi is. Mushrooms, mold, yeast. Fungi are heterotrophic and saprophytic, and they play a huge part in our everyday lives. They can cause mycoses, be decomposers, ferment foods, and are even part of antibiotics, like penicillin. That's right. Without fungi, we wouldn't have penicillin that can treat thousands of bacterial infections. Molds, which are multicellular fungal bodies, are made up of hyphae, a fancy word for filament, forming into a network of hyphae called mycelium and the body of fungi. These hyphae can be broken down into 2 further groups, septate hyphae and non-septate hyphae, or cenocytic hyphae. Yeast are the opposites of mold, for the fact that they are unicellular, which reproduce by budding. These budding yeast may stick together, forming pseudohypha, and some fungi can be both yeast and molds. These are called dimorphic fungi, and it can change depending on which environment suits them the best. This makes dimorphic fungi very adaptable. Cool, right? In addition, fungi uses chitin for their cell walls instead of the traditional cellulose in plants, and ergosterose for their cell membranes instead of the traditional cholesterol in animals. They also reproduce in a special way. Instead of male and female, they have plus and minus types. Haploid fungi have hyphae with gametes at the tips, and the plus and minus gametes fuse during plasmagamy to create a dikaryotic cell. Then, it undergoes karyogamy, where the nuclei join together to make a diploid zygote, which goes through meiosis to form spores. It can also reproduce asexually using mitosis, budding, and hyphae fragmentation. But I'm going to assume you guys know what that is so we can keep chugging along. And of course, fungi are divided into groups. Man, microbiology really loves their groups. There's 7 of them, but we're only going to focus on 4 of the relevant ones. Zygomycota, Ascomycota, Basidiomycota, and Mycosporidia. Because why cover something we don't need? Let's go in alphabetical order to make memorizing this easier. The first one is Ascomycota. This includes foods like mushrooms and truffle, bread molds, and other pathogens. Penicillium also falls under this category, and also other nasty infections like athlete's foot and valley fever. And the Ascomycota loves their A's. Get ready. Some Ascomycota have septate and ascocarps. They also produce ascospores and conidia. They even have an ascus, and even better, the Asparagus flavus, a species belonging to the Ascomycota group, produces aflatoxin. Our straight A student. We love that. Next on the list is Basidiomycota, and if you couldn't have guessed, this one really loves their bees, including mushrooms, puffballs, and rust. It has a basidia that makes basidiospores in their basidiocarps. They decompose stuff, and they can be food, or poison. The next one is Mycosporidia, and to all of our disappointment, it does not love its M's. Most of these are unicellular and parasites, as you will see in their special organelles. It does not have a mitochondria, peroxisomes, or centrioles, but it does have a polar tubule that allows the fungi to pierce the cell membrane of the host and burrow its way in. And lastly is the Zygomycota, which I shall discuss pretty briefly here. Does not love its Z's, are saprophytes, have sinusitic hyphae, and a haploid nucleus, and produce sporangiospores and zygospores. See, that wasn't too bad, was it? Not as much memorizing and grouping as the first one. Well, I have good news for you. 5.4 and 5.5 are the shortest, sweetest, and simplest. We're almost done. Let's jump into algae and get this done and over with. Algae. You know the thing that you see floating in fish tanks? Yep, that's algae. Algae are autotrophic protists that are very important to oxygen production in water environments, used in things like agar, and are an important food source to many organisms. They also have a bunch of special organelles that set them apart from other things like plants. For example, they have one or more chloroplasts that contain pyrenoids, and most of these chloroplasts have 2 cell membranes, although some can have up to 3 or 4 due to evolutionary processes. They can also be different colors due to the pigment it makes, and can produce both asexually and sexually. How do we classify algae? Well, remember the 7 big supergroups of eukaryotes that we covered way back in 5.1? We're going to go right back to it. The first one is Chromoviolata, which you might remember as our pizza. In algae, the Chromoviolata group can be broken down into 2 different subgroups, the dinoflagellates and the straminophiles. Dinoflagellates are marine organisms and can be phototrophic, heterotrophic, or mixotrophic. Phototrophic dinoflagellates use chlorophyll A and C2, have 2 fun little flagella, and some have a theca as armor. Fun little fact about me, I love flagella. I don't know why, but the thought of a cell just wearing its little flagella around is adorable to me. Do you get what I mean? Despite this though, dinoflagellates can be pretty dangerous. Some produce neurotoxins that can paralyze humans, and if they grow close together in a dense population, they can create a red tide. Not good for fish, and not good for humans either. The second type of Chromoviolata is the straminophiles, which include golden algae, brown algae, and diatoms. They make chlorophyll A, C1, C2, and fucoxanthin for their pigmentation, and use chrysolaminarin as their stored carbohydrate instead of starch. Diatom has frostrils and can produce sexually and asexually. Male diatoms have a bunch of flagella to find the female diatoms to sexually reproduce. Brown algae specifically make chlorophyll A, C, B-carotene, and fucoxanthin for pigmentation, use laminarin as a storage carbohydrate, and are a big multicellular marine seaweed with blades, stalks, and holdfasts. The second supergroup that algae can fall under is archaeoplastids, which we haven't really covered yet. These include green algae, red algae, and land plants. All green algae make chlorophyll A and B, have cellulose walls, and use starch as a carbohydrate storage molecule, very, very similar to land plants. That was short, wasn't it? That's all there is to algae. We're almost at home base. Stick with me, guys. Now, let's do some lichens. This is probably the one you guys are the least familiar with, but the concept is pretty simple. Lichens are either green algae or cyanobacteria living in a symbiotic relationship with a fungi. They do not cause any illness or infection, but they still play a huge part in our ecosystem by breaking down rock, acting as soil stabilizers and a nitrogen source, and can be used in medicine and antibiotics. Some scientists say that lichens are living in a mutual relationship, but you will more commonly find textbook and sources saying that they are a parasitical relationship. While fungi can get nutrients and photosynthase from the algae or cyanobacteria, the algae and cyanobacteria grow less well with the fungi on it. They can be found on rocks or plants. Their body is also made up of 3 parts: the cortex, the medulla, and the rhizines. And of course, lichens can be broken down into 3 subgroups. There are the crustose lichens, the foliose lichens, and the fructose lichens. Oh my goodness, we're done. That's it. That's the entirety of chapter 5 summarized by a girl who is very mentally unstable after making this. I really suggest that you read the OpenStax textbook and skim over it as well, because I did leave out a couple of facts and information. But I hope you enjoyed my diagramming and pictures, and maybe this helped? I don't know. I'll go hibernate for 4 years now, bye.